Hello everyone, welcome to EV charging system configuration, operation and control class. I am Dr. Shailendra Kumar, Assistant Professor in the Department of Electrical Engineering, IIT Bhilai. Under this lecture, today we will discuss about DC-DC converters, the importance of DC-DC converter with its control for electric vehicle charging. So, today under this lecture we will discuss introduction, types of DC-DC converter, what are the types, what are the classification of DC-DC converter and what types they are categorized, like isolated and non-isolated. We will see charging modes, how we are switching from constant current to constant voltage, then few control strategies. Then we will see the design, control and implementation of dual active bridge converter for EV charging. What is the design, what is the control, how the power is transferred from primary to secondary or from input to output as well as from output to input. Then we have a Scott connection based DAP converter for EV charging. We will see what are the disadvantages of a Scott connection based dual active bridge converter as compared to the two winding dual active bridge converter. We will see the challenges and application. We will also go through the emerging control strategies for DC-DC converter, what type of control strategies can be utilized for efficient operation of DC-DC converter in EV charging. And finally, we will come across conclusion and future scope. So, we will see here the introduction of DC-DC converter, why the DC-DC converters are important. Due to rapid development of modern energy applications such as renewable energy, photovoltaic, wind energy conversion system, electric vehicles and a smart grid, DC-DC converters have become the key component to meet strict industrial demands. More advanced converters are effective in minimizing switching losses and providing an efficient energy conversion. So, in case of electric vehicle applications, DC-DC converter can regulate the voltage and current. However, in case of renewable energy source like photovoltaic system, various DC-DC converters, isolated and non-isolated, they are utilized to achieve the MPP point. In the sense, maximum power is extracted from the photovoltaic by using these DC-DC converters. The main challenge is to provide a single converter that has all the required feature to deliver efficient energy for various types of modern energy systems and energy storage system integration. These DC-DC converter are also available under the category of bidirectional conversion units. So, some of the converters, DC-DC converters, they have the capability to operate in both ways. They can, input can act as a output as well as output can act as a input. So, these type of converters are very famous in EV applications. where sometimes we need to draw power from the utility grid, sometimes we have to operate in vehicle to grid mode. Therefore, these bidirectional converter units, bidirectional DC-DC converter units are playing a vital role. They can, if battery is available, so they can inject the power which is drawn from the battery to the grid to support the grid under peak load demand. However, when battery is discharged or SOC of the battery is less than the permissible limit, like it is hitting the lower limit of 20%, these converters can charge the battery by extracting or taking power from the grid by regulating voltage and current at the DC bus. So, these bidirectional units are very famous in case of energy storage elements. So, applications, one of the major applications is electric vehicle and charging infrastructure. So, here we can see these two figures where one PV modules or PV cells, I mean we have utilized PV module over here, various cells they are making the PV module. So, in one cell suppose 54 cells are there and all these cells are connected in series, they are making a PV module and this module is installed at the roof of a vehicle. For extracting this maximum power from this renewable, we need this DC converter, and as this PV cell or PV module is acting as a source, only one directional DC-DC converter is required, or we can say unidirectional DC-DC converter is required for extracting the maximum power. However, toward the battery can act as a sink and source. So, in this case we need to have bidirectional DC-DC converter unit along with the battery bank or battery pack. Why? Because when the vehicle at the rest, so there are two major applications of DC-DC converter here. When the vehicle is at rest, what is the purpose of putting DC-DC converter? When the vehicle is moving, what is the purpose of this DC-DC converter when somebody has applied the brake or when it is operating, the vehicle is operating in motoring mode. So, whenever PV is at the vehicle is at the rest, we can charge battery through PV source by operating these bidirectional converter in buck mode. The power can be injected to the battery. Similarly, if one could find out there is need to operate these vehicle and now we need to discharge this battery, as soon as the machine is started and vehicle starts moving, the power will be drawn from the input of this inverter. So, there is decrease in the voltage at the DC bus. To support this voltage, to inject the power at the DC bus, this bidirectional DC-DC converter must operate in boost mode, so that battery can push the power at the DC bus to maintain the DC bus voltage as well as inject the required power at the DC bus, so that we can operate our vehicle and we can accelerate our vehicle. The another example, I said that when vehicle is moving and we have applied brake at the to the vehicle. So, in that case there will be a regeneration, braking operation will be there, and some converter we have to utilize, some bidirectional converter we have to utilize. So, the energy which is generated during braking operation, it should be fed back to the battery. So, from the PV cell we have to charge a battery, from the when the vehicle is operating in braking mode we have to charge the battery. However, when this vehicle is operating in motoring mode we have to draw power from the battery. So, this bidirectional DC-DC converter should operate in both way. Therefore, the application in electric vehicle of these DC-DC converter is very important. And other side we may have some proposed bidirectional integrated DC-DC converter, and they can communicate with the PV cell, with the battery and with the inverter, and depending on the operation they can be controlled. Another important application of DC-DC converter is renewable energy. I mean, the use of these DC-DC converter is widely used, the DC-DC converter are widely used in case of renewable energy where we are extracting maximum power. So, these DC-DC converters are utilized in case of wind power conversion unit, in case of photovoltaic system, in case of fuel cells, where these DC-DC converter can use to do the MPPT, maximum power point tracking. So, one algorithm is utilized. There are n number of algorithms which are available to achieve the MPPT. We have taken the input voltage and input current from the PV module or from the wind based plant, and then these input voltage and current, PV voltage and current are supplied to the MPPT control. It could be incremental conductance based control or some perturbation observer based control, which is generating duty cycle at certain switching frequency to control these DC-DC converter. And one important thing, these DC-DC converter, they are supplying constant, I mean these DC-DC converter are helping renewable energy sources so that they can realize constant impedance, because you cannot control the load where the resistance is varying throughout the day. If resistance is varying, your MPPT point may move left or right. In that case, these DC-DC converter, they are helping to provide constant impedance to the PV module, so that they can see RT total impedance offered by this load plus DC-DC converter is constant, and they can adjust the duty cycle so that the maximum power can be drawn from the PV array. Further, people have utilized these DC to AC conversion unit so that they can communicate with the power grid, AC loads, and these DC loads are also connected at the DC bus, where these DC to AC conversion unit is not required, as they are DC in nature. And many more applications are also there for these DC-DC converter, like in HV AC systems, propulsion systems, and auxiliary and emergency systems. Many other industrial DC-DC converter can be integrated in any system that need to address power fluctuation, regulated power supply, or compensate for voltage drops. These DC-DC converter are also very famous. Nowadays, people are using in LED lighting. So, the application of DC-DC converter are not restricted only for renewable or for electric vehicles, but the applications, some application like lighting and some other applications people are using these DC-DC converters. So, let us see the classification of DC-DC converters. So, DC-DC converters, they are classified in three part: linear mode, where it can operate as a series regulator and shunt regulators. DC-DC converter are also classified depending on the soft and hard switching mode. So, if you see the hard switching mode, they are categorized as a isolated and non-isolated. So, isolated converter, we have multiple switch based converter and one switch based converter like boost, forward, buck, flyback, where one inductor and one switch and then transformer are utilized. However, one diode it is also used in that case. However, we have multiple switch based converter and these are named as push, pull, full bridge, half bridge converters. However, other side if we see, we have soft switching resonant converter and they are categorized depending on either we are going for 0 voltage switching or we are going for a 0 current switching. These ZCS and ZVS are helping to reduce the switching losses significantly. So, that is why these DC-DC converter people are controlling in ZCS and ZVS mode, where during transition suppose I am switching the device. So, I square all losses will take place during on state, and when I am going to apply off pulse to the converter, then again device will switch from on state to off state and there will be some losses. To minimize these hard switching losses, people are going for soft switching based scheme and they are categorized as a 0 voltage and 0 current switching. Now, so we have certain standard type DC-DC converter and these standard DC-DC converter are classified depending on the application. What is the voltage requirement at the output of this converter? So, here we have three basic standard converters, DC-DC converter. One is buck converter, another is boost converter and the third one buck boost converter. So, in buck converter it steps down the voltage for EV battery charging. Suppose one front end converter we have taken. So, this diode based front end converter and we have selected 3 phase 415 volt grid. So, 415 will be converted into using the diode rectifier, it could be around 580 or 600 volt. So, this 600 volt will be stepped down as per your requirement. Suppose 48 volt battery is selected. Similarly, for single phase application, suppose single phase front end converter we have utilized for AC to DC conversion unit. So, single phase source it is available in India as a 230 volt and 50 hertz supply. This 230 will be converted into 325 or 310 volt. This 310 volt can be stepped down using buck converter, right, because battery requirement is suppose 48 to 72 volt. Later on we will see if voltage gain is high, then we have to go for some other topologies, but these conventional control converters can also utilize to step down the voltage. So, 310 can be converted into can be stepped down using buck converter. So, you can see the right side we have the topologies. So, using one switch, one diode and one inductor, using these three components we can develop a buck converter. So, here the switch is in series with the supply. However, in boost converter the switch with parallel with the supply and the inductor in series, and then we have boost converter. Now, if we move to the buck boost converter, the switch is in series with the input and then one inductor, and the diode is connected, and then in all three units we have a capacitor which is utilized to mitigate the ripple in the voltage. Now, the operation of buck converter, suppose we have provided on signal to this switch. As soon as the switch is on, inductor stores the energy, and the moment when you switch off the switch, then stored energy of the inductor is free wheel through this diode. So, capacitor get charged and capacitor will supply this energy to the load or to the battery. Similarly, in case of boost converter, when switch is on, inductor stores the energy, and when we release the switch, diode will be in forward bias, and this inductor energy is stored in capacitor, and capacitor further release the energy to the load. So, this way we can achieve the buck and boost converter operation. Similarly, we have this buck boost operation where it can do both the function, it can provide the flexibility during the voltage regulation. And these converters we can utilize in onboard chargers and for charging infrastructure. First, we have seen the non-isolated basic standard topologies, now non-isolated. Now, we will go for isolated type of EV charger. So, here we can have more converters under the isolated type, but here we have shown basic three topology. One is flyback, and the application of flyback is for low power. It is widely used in the SMPS, switch mode power supply, computer power supply, laptop power supply. This flyback converter is very famous. It is a simple isolated converter, and using one switch, one transformer. This is the high frequency transformer, it is not a 50 hertz transformer, because here switch is on at very high switching frequency, and for these high switching frequency we have designed this inductor. So, as soon as you are increasing the switching frequency, size of the transformer will reduce, as the size of the transformer or the value of inductance is inversely proportional with the switching frequency. So, in many applications people are going for a higher switching frequency, so that the size of the transformer can be reduced. And simple operation as a converter which we have seen in last slide. Here when the switch is on, inductor gets primary of the inductor gets charged, and the moment when you release the switch, the primary energy is transferred to the secondary, and as the diode will become in forward bias, the dot convention will change, and this inductor will release the energy through diode to the capacitor, and this capacitor will further release energy to the load. Another topology, we have forward converter, and it provides very higher efficiency for medium power applications. We have full bridge converter used in high power EV charging station, as this converter is able to provide the isolation. So, safety critical systems of board charger useful in interconnection system. Now, we have CC and CV. So, when the battery is hitting to the lower limit, we can go for constant current charging, which ensures the safe and fast charging without any overheating. However, as soon as the battery achieves the nominal voltage The constant, we can switch to the constant voltage mode, which maintains the constant voltage and gradually reduce the charging current, and the battery approaches to full charge. How CCCV works? In the early phase, the battery, as I discussed, battery charges in CC mode until the voltage reaches a predefined level. Once the voltage achieves the predefined level, it can switch to the CV mode. What are the challenges in EV charging? One is the efficiency. We have to increase the efficiency of these DC-DC converter. We have to switch these devices at very high switching frequency, so that the converter size, transformer size could be reduced. We have to provide thermal management also. Thermal management is also one of the challenge in case of EV charging. Heat dissipation must be proper. Battery life, avoiding overheating and ensuring long life of the battery through precise control. So, that we should not inject any kind of ripple to the battery which may degrade the battery life. Isolation and safety is very important when we are talking about the fast charging. Whenever we are talking about DC fast charging, isolation and safeties are important. People have given proper standard for safety, and they have well established standard for safety and protections. Grid impact, managing the impact of large scale EV charging on the power grid. Now, we have control technique for EV charging. The control technique here we have divided into 4 parts. First one is linear control. So, simple PI control can be utilized for stable charging. People are also using to improve the dynamic response when the battery is switching from charging to discharging and discharging to charging mode. So, nonlinear control are utilized for fast response. So, these nonlinear control are sliding mode control for robustness and when any disturbance is happening. MPC, people are using model predictive control to optimize the performance, dynamic performance. Then finally, people are using disturbance observer based control, which improves the control performance by estimating and compensating for system disturbances. Challenges in converter control: disturbance rejection, voltage ripple, current control, and dynamic performance under V2G and G2V mode. So, here we can see the first dual active conventional dual active bridge converter, where we have 2 bridges, 2 H bridges, and both the side we have DC. So, DC input we have used as a V input DC input, and at the output we have connected this lithium ion battery of a vehicle. These 2 units, input and output, they are isolated through a high frequency transformer, and the first unit and the power transfer, as we can see in the another figure, power is transferred from source to battery as well as from battery to the source. So, this converter is perfectly applicable, or it can perfectly work for V2G and G2V mode of operations, where the phase difference decides the power flow between input and output or output to input. So, it is these converters simply, I mean, they are operating, the magnitude of current will be decided based on the phase difference, what is the phase difference between input and output, and the energy will be transferred. So, in conclusion, in this particular lecture we have gone through various DC-DC converter, conventional DC-DC converter, or we can say standard DC-DC converter, then isolated DC-DC converter. What are the applications of DC-DC converter? That is very important. So, widely people are using these DC-DC converters, isolated and non-isolated, in EV charging, in renewable energy, and for LED lighting, and for some other industrial applications. Future outlook: integration of advanced control strategies and new semiconductor technologies for next generation EV chargers. We can explore the SiC GaN based devices to integrate the charger with the EV, and we can improve the efficiency further. So, thank you very much for listening this lecture. Thank you very much.